Welcome to Gradient Daily. Today, we are diving into a paper that is an absolute monster, a true game changer in 3D computer vision. We're talking about the CVPR 2025 Best Paper Award winner, VGT. This thing comes straight from the legendary minds at Oxford's Visual Geometry Group and Meta AI, and trust me, its impact is going to be felt everywhere. So let's just get right into it. If you've ever, and I mean ever, worked in 3D vision, you know the pain. You go out, you take 100 photos of a building, you dump them into your machine, and then you go make a coffee, maybe lunch. Because for a field that's supposed to be about creating the future, the main process feels like it's stuck in the past. It is just so slow. Why? Well, the bottleneck, the main villain of our story, is a process called iterative optimization. For decades, the gold standard for getting this stuff right has been a super complex, multi-step process, with this beast called bundle adjustment right at its core. Now, don't get me wrong, it's incredibly precise, but it's also incredibly slow, chewing through compute for minutes, sometimes even hours, just to get one scene right. And that's exactly the problem VGGT is here to kill. All right, so here's the game plan for today. First, we're going to dig a little deeper into that old optimization problem. Then we'll introduce VGMT, the hero of the hour. We're going to pop the hood and look at its architecture, then see the proof in the pudding, how it just completely destroys the benchmarks. And finally, we'll talk about why this isn't just another model. It's a whole new foundation for 3D. Okay, so let's really set the stage here with the old way of doing things. You know, traditional structure for motion, or SFM. It's this long, clunky pipeline. First, you've got to find matching points between all your images. Then you triangulate those points to guess their 3D position. And then you have to run that super slow bundle adjustment process to clean everything up. It's a lot. So you've got two camps, really. On one side, you have the classics like COL and MAPE, super powerful, but they're built on that slow, iterative foundation. Then, on the other side, you've got these newer ML models like DUSTS3, which were a great step forward. But here's the catch. They can only look at two images at a time. So to build a whole scene, you have to run it over and over on different pairs. And then, you guessed it, use another slow process to stitch all those little pieces together. Either way, you're stuck in the waiting room. And this, right here, is where VGT just flips the table. This isn't an improvement. It's a complete paradigm shift. Forget the messy pipelines. Forget the one pair at a time approach. VGT is one single, unified, feed-forward network. And this is where it feels like actual magic. You give VGGT a whole batch of images. Doesn't matter if it's 10 or 200, and in one single forward pass, it just gives you everything. The camera poses, the dense depth for every single pixel, consistent 3D points, even tracks of those points across all the images. No pipeline, no fusing, just one shot, the whole shebang. And just look at this. This is what comes out the other end. You've got this beautiful, crisp, detailed 3D point cloud, and you can even see the little camera positions it figured out on the side. This is the kind of quality that used to mean minutes and minutes of your life disappearing into a progress bar. Now, it's generated in the blink of an eye. So the big question is, how on earth does it do that? Okay, let's pop the hood and get into the architecture, because this is where the real secret sauce is. Okay, so at its core, VGGT is a beefy 1.2 billion parameter transformer. It kicks things off using a Dino Vision backbone to chop up all the images into little pieces or tokens. Then, and this is clever, it adds a special camera token for each image. All of these tokens, image parts and camera placeholders, get thrown into the transformer's attention layers to mix and mingle. And at the very end, a couple of specialized heads read the output and spit out the camera poses and all the dense 3D information. But the absolute key innovation here is this idea they call alternating attention. The detective analogy is perfect for this. Imagine a detective investigating a crime scene spread across multiple rooms. First, you have frame-wise attention. That's the detective searching for clues inside each individual room. Then you have global attention. That's the detective stepping out into the hallway to figure out how the clues from all the rooms connect to each other. VGGT just does this over and over, alternating between looking at individual images and looking at the whole scene until it has this perfect global understanding of the 3D space. It's brilliant. An awesome architecture is one thing, but the proof is in the pudding. Does it actually perform? Well, let's look at the numbers, because this is where VGGT just comes in and drops the mic. All right, just look at this table. Focus on that hours feed-forward row. On the Real Estate 10K dataset, it hits a score of 85.3. That doesn't just beat DSTR3, it leaves it in the dust. And it even beats the slow, optimization-based VGSFM. Now, look at the time column. The others are taking 7-10 seconds. VGT, 0.2 seconds. It's not just better, it's over 35 times faster. And get this, if you do decide to add that old-school bundle adjustment at the end, the accuracy skyrockets to 93.5, and it's still faster than everything else. Just wow. And this isn't some abstract number on a spreadsheet. You can literally see the difference. On the left, that's the VGGT reconstruction. Look how sharp and clean the geometry is. Now look at the result from a prior SOTA model on the right. The difference in quality, the lack of noisy floating garbage points, it's just night and day. Let's just sit with this for a second. 0.2 seconds. That is absurdly fast. This isn't just an incremental improvement. This single number changes 3D reconstruction from a slow, offline batch process into something that feels interactive and real-time. It completely unlocks new applications that were just impossible before. And it's not just one lucky punch, it's a total knockout across the board. On multi-view stereo, it demolishes Dust3. For point map estimation, way more accurate, and again, ridiculously faster. But here's the really wild part. It even beats models that were specifically designed just for matching two images. It's a generalist model that's winning the specialist game. It's a total clean sweep. So when you see performance like this across so many different tasks, it starts to feel like VGGT isn't just a better tool for doing the same old job, it's actually a brand new kind of building block for the whole field of 3D vision. And the authors prove it. They show that you can take the brain of a pre-trained VGGT model, its feature backbone, and plug it into other models to make them better. They dropped it into a novel view synthesis model, and boom, performance shot up. They used it to power a dynamic point tracker, and boom, same thing, huge improvements. This is what I mean. Take a look here. They replaced the core of CoTracker, a model made for tracking points in videos with lots of motion. And even though VGGT was trained on static scenes, its understanding of 3D is so deep and robust that it dramatically improves tracking in these dynamic scenes. That's incredible generalization. It's excelling at a task it wasn't even built for. And really, the authors say it best themselves. They're not just tweaking things. They've created a new foundation for fast, reliable, and versatile 3D reconstruction. They're not just building a better mousetrap here. They're basically handing everyone a whole new type of factory. So, if you're going to walk away with just 3 things, let it be these. 1. Unification. VGGT takes that whole messy multi-step pipeline and turns it into one single elegant model. 2. Speed and quality. It hits a new state-of-the-art in reconstruction quality while being insanely fast. No more trade-offs. And 3, it's a true foundation model for 3D. Its features are so good they can be used to lift up an entire ecosystem of other 3D tasks. The takeaway here is huge. By killing the slow, complicated pipeline, VGGT is opening the door for real-time, high-quality 3D perception in robotics, in augmented reality, everywhere. The question isn't if we can rebuild our world in 3D anymore, it's how fast can we do it on every single device out there. If you enjoyed this breakdown, make sure to hit like and subscribe to Gradient Daily. We'll see you tomorrow with another paper. Thanks for tuning in.